Hello everyone, this is the video lecture for 7.2, Law of Cosines. I'm going to give you my preferred formula. Um, there's I think there's 6 different versions of this, but I'll just write the one because they're all basically duplicates. So cosine squared is equal to a squared plus b squared minus 2ab times cosine of c angle. What happens is that if you have a side angle side kind of triangle, you can, I think that's what it is. Yeah. Basically, you could take this and solve for it. You cannot do that with law of sines. But in the end, we're still going to use law of sines after we're done with the law of cosines. So I still want to have this around where this is still a very appropriate formula. And of course, then the 180 rule will also be popping up again as well. All right, so that's all it is basically do this one first and then go ahead and back to the last section and finish it up. That's really all it's going to be. So 7, 2, 1. They give us this triangle, and I have a 35. I have a 5, I have a 10, and they say this is little a, so that's A, this is capital C, this is little b, so that's little b and little c, and blah, 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 blah. Okay, so notice that we have a side, angle, side, and so, again, you cannot do that normally with law of sines. It just doesn't fit anywhere, it doesn't plug in, and so we're just going to do it. So a squared is equal to, and here we go, 5 squared. 10 squared, 2 times 5 times 10 times the cosine of 35. This is all at once in the calculator, and what I got was 43.08479. Okay, a lot of decimals is good because this is a squared. You need to find just a. How do you do it? Square root. So you square root what you just had, and I've got 6.5639, and that's my answer for little a. I know it's not the scale, but whatever. And so that's fine. And so now that we have this last one here, we could do law of sines. And so in order to find b and c, let's say I'm going to find b. I'm going to do law of sines. Oops, it's over little a. Sine of b over b, and so I have a now is the 35 and 6.5639. B, I don't know what angle b is, but I know little b is a 5. So multiply it over arc sine. Since it's a new video, I'll just do it once here. But not I didn't really even do it. I'm just giving you what I'm typing in the calculator. Definitely refer back to the last video for all of that math. I got 25.907. Bam. To find C, again, I'm going to use the 180 rule, if at all possible. And here it is possible. Altogether, 119.093. And there it is. So, law of cosines, do it first, and then after that, use law of sines, blah, blah, blah. Okay. 7, 2, 11. So they say B is equal to 4, C is equal to 5, and A is equal to 100. Find all the rest. So I'm going to draw a picture, and because that 100 is obtuse, I'm going to try to do like that. I don't know what little a is. I'm going to make this up as a 4 and then a 5. So this is a C, this is going to be my B, this is going to be my A. And it's literally a copy-paste of the last problem. I mean, I don't know if you like being bored. Maybe you do. That's why you clicked on my video. I'm only half joking. Honestly, this is very repetitive math. 47.945. Like, I'm just looking at my notes here. So you could pause it and try to find what these values are for yourself and see if you're getting what I'm going to get. I mean, I might be wrong. I don't know. I try not to be wrong too often. Now that I have A, now I can do law of sines. So sine of the 100 over this 6.924. Let's find B, so sine of B, all over 4. So I move it over, arc sine. I did arc sine last time, right? I sure did. I mean, this is all just from the last section. Again, no problems. There we go. C is the 180 rule. I'm just going to quickly put letters because I'm super lazy right now. There we go. Ta-da! Okay. Hey, guess what? Let's do it again. This one's a tiny bit different, and so I am going to explain a little bit more this time. But again, once we get one of my answers with law of cosines, the rest just falls into place. Okay, so they're saying we don't have any of the angles, but we have all the sides, and so find all the angles. Now, what's funny is that in theory, this is possible. We're definitely going to be able to do this. But if you had all the angles but didn't have any sides, you couldn't do it. You can't. It's just a weird predicament where if you have all the angles, you can actually make similar triangles, and they all have the same angles, but the sides could be different. So, so that's not a good thing there. But in our case, it's okay because we have 3 sides, and we can get the angles. I don't know what they're going to be, but if you take like a 10, like a stick that's 10, a stick that's 9, and a stick that's 8, and you start moving them around enough, and you know we humans are very good at doing this sort of thing. You basically can make the triangle that you were looking for, and there you go. So that's what we're doing. But now, mathematically, how do we make this thing happen? Well, I'm going to do the law of cosines again, but now it's a squared is equal to b squared plus c squared minus 2 times the 9 times the 8 times the cosine of a. So we need to solve for a. What I do is I actually subtract these over to the other side, and then I'm going to divide this over here. So because this is, I would say this is an upper level class. I know it's one of the beginning upper level classes, but still it has, it's math 2412. That number says that I can skip a few steps. No! Chad, you showed me everything. Oh, that was just me being a little bit mean. Arc cosine to the other side. Okay. I'm just being silly, okay? I'm looking, and yeah, okay, good, yes, good. Okay, yeah. So I did this in the calculator. I got 71.79 degrees for my A, and there you go. What we could do is law of sines now in order to get the next one. On my notes, I do law of cosines again, but I'm not going to do that. Instead, I'm going to do law of sines because that's what I told you to do, and that's fine. So sine of the 71.79 all over A was a 10. Sine of the B all over B, which was the 9, I believe. So move that over. Arc sine. We should get our answer pretty quickly here. multiply. Okay, there we go. Okay, arc sine 9 times sine of the 71.79 divided by the 10. I probably just look at my notes next time. Yep, there we go. 58.7515. There we go. To find my C, I'm just going to do the 180 rule. You know, with less rounded answers. And I got 49.4584. Whew, did it. Now we can actually move on to like fun stuff, okay? So 7 to 25. And I'm kind of sad that they don't have a lot more of these kind of problems. I'm also sad that this is isosceles. You don't have to have it this way. Anyways, they say find the area of this triangle using Heron's formula. Now, Heron's formula is near and dear to my heart. It's something I've used on my own on like other projects and stuff because it's so versatile and it's incredibly good. So what do we do here? We got 3 sides to the triangle, and I'm going to make an isosceles. Actually, it should be more like this. Okay, so I got 7, 7, 4. You know, there's probably a formula for an isosceles triangle, like area of isosceles. Just saying. But that's not what we're doing here. My math lab just happened to have a 774. It could be a 784 next time. You never know. So the point is that we need to learn Heron's because it's going to be more generalized. Okay, so how do we do this? Well, Heron's formula is a 2-part problem. So little s is equal to a plus b plus c all over 2. I know it's a little bit an odd formula there, but then my area, the actual area, is going to be the square root of s times s minus a times s minus b times s minus c. And so I need to find s first. So that's going to be a 7 plus a 7 plus a 4 all over 2. 18 over 2 is a 9. So I'm going to put 9s all over the place. So here we go. I got the square root of 9 times 9 minus 7, 9 minus 7, 9 minus 4. When you put all that in the calculator, I got square root of 180, which simplifies down to 6 square root of 5, which is exactly what they're looking for. Or maybe not. Maybe they're looking for the approximation. I have both boxed in, but if you needed to go this way, that's fine. If you needed to go to the calculator, that's fine too. I'm sure that you can do this. Remember, this was right here. There's a 2 in the front, so I could do that. Man, am I going to use that again and again? Mean. No, it's fine. You know this is fine. So Heron's formula, pretty cool. Let's do another problem. I don't have very many left. We're getting pretty close to the end here. Okay, so there's this line, and it's coming off, and this thing's shooting out over there, and wow, that is terrible. Close enough. So there's a C. I have an 8. I have a 13. I have here is 14 degrees. This is a 35 degrees. I know, not to scale. It's fine, whatever. So this is capital C, this is capital A, this is capital B, and solve for all the other things. Well, you can find your angle C here. Notice that it's like the complement stuff, and so I'm actually going to do a 180 thing. It's not like a 180 rule necessarily, but kind of at the same time. So I put all those together, and I got a 131 degrees. So that's what this is right here. So this guy right here is a 131. If I could draw that a little bit better. There we go, close enough. You can't barely read it anyways. So yeah, that's actually one of the answers. Now we can do law of cosines. C squared is going to be equal to a squared b squared minus 2 times a times b times the cosine of c. square root all that. I got the square root of 369.46 blah 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 is equal to 19.2213. Okay, and now that we have that, we can now do law of sines. I mean, this is like a very much like step-by-step process here. Sine of A over A. So I got sine of the 131 over the 19.2213 is equal to sine of A, which I don't know, over 13. Solve for A, so multiply it over, arc sine. Calculator, and I got 30.69 blah 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 after that. To find my B, I do the 180 rule. Surely you're sick of this at this point. It's really not too bad, I promise you. 18,307. Okay. If anything's overwhelming, it's just the amount of questions and parts and components and all that stuff. Okay, so I got, 1, 2, 3, 4 more problems. They are different though, so 7 to 33. So it's oh, I said I'm just going to set it up. Oh, that's so nice of me to not do the math. So I'm actually not doing the problem here. There's 3 circles, and they're of different radiuses. And that, yeah, hold on, let me try that again. They're all touching, like how you would expect. There you go. Okay, so given that I think that we have the radiuses, let's find out the angles and stuff like that. And so the radius for A is 5. That didn't look like a 5. 5. The radius for B, oh, well, not to scale, okay? The radius for B is a 4.1, and the radius for C is 2.7. So not to scale, not to scale. Okay, so how do we find out the lengths then? Well, notice that my C, or I'm sorry, this length right here is going to be an A and then also a C. And so the AC line, which is little b essentially, yeah, AC line little b is equal to the 5 plus the 2.7, which is equal to 7.7. My AB line right here, which is equal to little c, is 5 plus 4.1, 9.1. And then my BC line right here is little a is equal to the 4.1 plus the 2.7, 6.8. Now that we have our sides, right, basically have all these sides here, you can now find the angles just like the last problem. So I'm not going to do it. It's way too repetitive, man, way too repetitive for a cool video like this. And so here's a new one. And this one definitely is a little bit out there, okay? Once we get to a point where we can get the answers, it's going to be no problem. But for now, here we go. They give us these 3 points, and they say find the angles for the triangle it makes. All right, well, here we go. Let's start drawing something. Okay, so 0, 0, that's going to be my A. And then I've got negative 3, 1, 2, 3, 5, 1, 2, 3, 4, 5. There we go. There's my B. And then 3, 1, 1, 2, 3, negative 1. And this is my C. Unfortunately, it looks like they're almost on the same line, which it's not. It's just so close. Come on now. Okay, look. Do it. Do it. Do it. Do it. Do it. Ah, we got it. Just keep trying again and again. That's digital is really nice in that way. Anyways, so to find my AB, which again is my little c, how do I find the distance from here to here? Guess what? Pythagorean theorem. Yep, you're going to do Pythagorean theorem 4 times. And so the formula is x2 minus x1 all squared. And then we got y2 minus y1 all squared. And so here we go. I have, for AB, I'm going to have a negative 3 minus 0 squared. Then I got a 5 minus 0 all squared. And so this ends up being the square root of 34. And you don't have to convert that right now. In fact, leaving it as square root 34 is preferable because we're going to be using it here in a second for something else. Okay, AC is little b. So using my A and C values, I'm going to do 3 minus 0, negative 1 minus 0. Do the math, square root of 10. BC is my little a. And so these are going to be a little different now. So I've got 3 minus a negative 3 squared. So that's going to be like plus, 2 negatives make a positive. And then I got negative 1 minus 5 and then square it. So when you actually do the math, it's square root 72. Now that we got our 3 sides, now you just do the law of cosines and blah, 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 just like the last problem. And just like the problem before that. And just like the problem before that. And just like the problem before that. And that was it, actually. I think that's all we've had. So, ooh. All right, here we go. 7 to 39. I have a big picture here. I think it's like 2 boats or 2 planes leaving a dock or something at the same time. And so they say that this one here is south 15 degrees west. And they say that this is north 75 east. And so this angle here is 75. This angle here is 15. And they're saying, what's the distance between them? What's that distance between them? After 3 hours. Okay, so this boat here is traveling at 10 miles per hour, and this one here is traveling at 9 miles per hour. They're saying, what's the distance after 3 hours? Okay. Well, 3 hours, 10 miles an hour, 30. 9 miles an hour, 3 hours. 27. And so I could just redraw this. Say this is 30. This is 27. And you can find this angle on the inside and all that pretty easily. So notice that this angle here, like this angle here is 15, and this angle here is 75. What you can do is say that this is a 90. And then you can find the opposite of this is going to be another 15, I believe. So you're going to have a 15, a 90, and then another 15 on the inside to find this angle here. So that angle, again, I'm going to say it's the 15 plus 90 plus another 15 is equal to 120, I believe. Yeah. And so we could do law of cosines, and I'm actually gonna do this problem. I will do this problem. I will actually get an answer for this problem. Wow, Chad, you're actually doing math. You're actually doing your job finally. I know, isn't it so cool? I got 2439. And so then D is going to be the square root of 2439, which is the 49,386. And there's your final distance, okay? Miles or whatever. Oh, no. 49 point. Sorry, handwriting. Point. I'm going to try to clarify that on my notes there. That's a point, not a comma. So 49 miles. Okay. Last one is a GeoGebra question, but I have a little note in my notes here, and it says there's many more application questions, but all are pretty easy. So I went through and looked at them. I could sit here on this section all day long, and it wouldn't help or hurt you in any way. I mean, you can copy from me, I guess, but what the idea is that you need to kind of explore on your own too. So have fun with that. It's the same. So GeoGebra number 16, okay? They give us a triangle, and I'm going to try really hard to make it look like what they have. There we go. So I got a 3, I got a 4, and then I got a 3.09. And this is A, this is B, and this is C. Okay. And they say find alpha, find beta, find gamma. If you haven't seen that in a while, that's a gamma. This is the next letter. They don't have A, B, C, D, E. They have A, B, G, D, E, etc. Their C is like way later. Okay, so how do we do this? Well, it's law of cosines. What they're actually saying is find like capital A, capital B, capital C, that kind of thing. So yeah, it's not hard. So you know what? Let's do it the good way. It's okay. 3.09 squared, that's my a squared, is equal to b squared plus c squared minus 2 times b times c times the cosine of a, or alpha. Move it over, divide, and so cosine a is equal to 3.09 squared minus 4 squared minus 3 squared all over negative 2 times the 4 times the 3. Oh, and then how do we get a by itself is an arc cosine. 49.92205. And you can repeat the same process for B and C. And so I'm just going to give you my answers right quick for this one. 82.10038. And then my C is, I use the 180 rule, but it would be all the same in the end. Anyways, there you go. So there's my last answers. And we're done with that section. Thank you very much and have a great day.